Hi, today we are going to see some basics about quantum computing. So, why quantum computing and how it differs from the conventional computing? As we know, computers understand zeros and bits. That means only two states, zeros and one. Now, how this quantum computers differs from operating on the same zeros and ones and able to store or operate in almost infinite number of states. For understanding that, we have to jump into the quantum basics from physics, where all depends on electron. In the conventional computing, the electron jumps from the zero states to one state, and that's all, or from 1 to 0. So there are only two possibilities available, 0 and 1. Whereas in the quantum computing, the same electron in a different arrangement, it can have numerous states. For example, this is a single story building. So from the ground floor, we can go to the top floor only once because it is having only one floor. Whereas in this case, we have the ground floor, first floor, second floor, and third floor. So even if we give the condition that a person has to climb one floor, the ground floor person can go to the first floor, and the second floor person can go to the third floor, and the third floor person go to the fourth floor. So the quantum computers can make the electrons to go to numerous states from a single level. So the calculation speed increases enormously. So for better understanding, we have to go back to the classical and quantum physics. When compared to the normal computers, the quantum computers are very bulky, and the initial investment, hardware, everything is very huge, but they are very fast beyond our imagination. So this is the traditional processor, which is very small. To understand the difference between classical physics and quantum physics, let us take the example of train. It is having numerous compartments. When it is at rest, we can see the gap between the compartments. And when it is moving, it is very tough to find the gap. The same thing happens in a classical physics. The energy is continuous. That is like between the values from 0 to 1, we can have infinity values like 0.0012 to 0.999991. But in quantum, the energy is quantized, that is, it is fixed. So between 0 to 1, we can have quantized values. For example, 0.1, 0.2, 0.3, like that. So between 0 and 1, you can have only 10 values. If you take 0.5, 0, 0.5, 1. So energy is fixed. So this is the major difference between classical and quantum computing. And when we say quantum computing, the wave function jumps in because the quantum physics considers energy as a wave. And as I told, it is quantized. So this wave function is finding the particle nature of energy in the wave. For example, we have a damped oscillation here. That is, the oscillation keep on decreasing and come to rest at a particular point. Assume this is like a bouncing of a basketball. Initially, it bounces a lot with a high amplitude. After each bouncing, the amplitude becomes less, and at a particular point, the basketball comes to rest. And during bouncing, we know the basketball is bouncing, but the nature is a wave nature. So the wave function finds the probability of finding a particle that is basketball in our case, at a particular point at a particular time. So when the time changes, the position of the particle changes. It is at 0 here, then it goes up, comes down. So the position and time changes. The probability of finding this value is our wave function. So we have a lot of phenomena involving in qubits or quantum computing. The first one is superposition. What is quantum superposition is the quantum system can exist in multiple states simultaneously until it is measured. That is, in the conventional computing, if we assume it is bit 0, that will be 0 forever. That is, that particular electron will be stayed the particular point unless we disturb, or at 1. But in the quantum computing, the superposition enables, even though it is at a particular point, it can have numerous positions, or we can find it in 2 locations or 3 depending upon the situation, right? That is because inside the wave, we calculate or we find the wave function psi at a time t is equal to 1 second. That is different from t is equal to 2 seconds. For example, at time is equal to 1 second, the qubit value is 0, and time is equal to 2 seconds, the value is 1. What will happen in between? Between that second 1 to 2, it may having intermediate positions. So depending upon the time inside the wave, it can have numerous positions. That is the specialty of quantum superposition. And now the spin comes into play. In the conventional bit, it is down spin, and the up spin are plus half or minus half. That is assumed to be zeros and 1. Now in the qubit, the same thing happens, and inclusion of wave function, this spin positions may vary. That will leads to numerous positions. So due to the superposition concept, the qubit or the quantum bit will not available only in 0 and 1. It will available in numerous positions. The another one is quantum entanglement, where the particle become interconnected or they interact with each other instantaneously, right? That is, they can influence from one state to another state. For example, we have 2 electrons at different states or different positions. According to the classical physics, we think that they are 2 individuals. But what quantum physics says or quantum computing says is, this electron will influence the other electron. So what is so big deal in this? That creates numerous states in between. If there is no interaction between these 2, they are like individuals. The number of states are limited to 2. But when they becoming interacting, we have infinite number of states. This is like 2 people connecting without talking. They can think about the other one. They can influence the other one without talking any letter or word. So similar situation. So due to this quantum entanglement, numerous states are created for the qubits. So due to this quantum entanglement, number of floors in the building increased. So originally it was the single story building where we can go from the ground floor to the roof. But here, since the number of states are increased, the qubits are having numerous opportunities to create and to move. So once they have numerous states, the possibilities for the quantum calculation or qubit calculation is enormous. So the next concept is quantum interference. So it is a basic phenomena where the particles, they interact with each other. For example, if you have two waves, two inputs, they can make constructive interference. For example, this one and this one, if they are matching with each other and they interfere positively, their amplitude is amplified, increased. Whereas in the second case, one wave goes in the downwards, the other way go to the upward. So automatically the output is zero if they are equal. This is destructive interference. So the states or the electrons will interfere with each other, producing either a constructive pattern or a destructive pattern like this. So what is the output? Interaction of two electrons have created this much of pattern, positions. So creating more number of possibilities for the qubits. So this is a simple experiment for a quantum interference. We have a single photon source and we split the beam into two. One is passed to a mirror and given to a particular position. By the same time, the other half of the wave is traveling to another mirror and reaches the same point. So at this point, wave from the same source, they are making interference. Depending upon the condition, they will produce either constructive or destructive interference. So they have negative interference, so they cancel out each other, and the positive interference, they add up to a higher value. Then we have the quantum parallelism, okay, n number of phenomena due to the inference. Another important thing is quantum tunneling. So that allows the particle to pass through unpassable energy barriers, enabling the operation of superconducting qubits and other quantum devices. For example, a person trapped inside a huge well cannot come out without the support of other people. So literally or generally it is not possible. By climbing that very tall wall. But what quantum tunneling says is, even though the infinite potential or unpassable energy barrier, we can have the particle outside the barrier. That is not by climbing the wall or overcoming the barrier, but tunneling through. It can make a hole below the wall and it can come out. This concept is called quantum tunneling. So traditionally, the barrier has to be crossed over, but what tunneling says is we can penetrate through. So this enables, if you trap a particle inside a box or a potential well, where the particle doesn't have energy to overcome the barrier, but still we can find the particle outside the barrier. This is the concept of quantum tunneling. From this concept, the particles are made available outside the barrier. In other words, inside a potential barrier, it will have numerous energy states ranging from the zero to the infinite potential, making the qubits to move n number of possibilities. So normal classical bit is having zeros and one, whereas the qubit is inside that potential barrier, it can have n number of values. This is given for the x-axis based on the spin of the electron. Similarly, infinite possibilities are available in the y-axis and in the z-axis. So this, because of this, we can have huge number of qubits in the quantum computing. So the bit of 0 to 1, another wave function psi 1, psi 2, psi 3. In the same bit, here it is having 4 states. Similarly, we can have infinity or more number of states based on their position.